So thank you, Minister Bethenfalvy. I particularly want to thank him for many years of his personal leadership, and I think if you check his track record on the work he's done around digitizing the Ontario government, you'll be just as impressed as I am. I'd also like to thank the Premier, Ministers Crawford, Fedeli, and Mulrooney for their partnership, and a special shout out to IP Ontario, who we've partnered with to protect over 100 assets to date, and we've got more coming in the future. Good morning, everyone. My name is Glenda Crisp. I'm the President and CEO of Vector Institute. Thank you for joining us here at Remarkable 2026, and welcome to our very large virtual audience as well. So I'm excited to dive into our very first conversation because we have someone here who represents exactly what this conference is about. I'm thrilled to welcome Nick Frosst, the co-founder of Cohere, someone whose journey embodies Canadian AI leadership. Nick's story starts in our research community. He studied and worked with Jeff Hinton at Google Brain, contributing to the foundational AI work that positions Canada globally. He then went on to co-found Cohere, turning research excellence into adoption. I guess in his part-time time that he's got available, shockingly, he also leads the Juno-nominated band Good Kid, and their debut album's coming out in April, so I'm going to keep an eye out for that, and I encourage you to do likewise. But that's a perfect example of how creative thinking can span disciplines. Cohere has grown to a $7 billion valuation by solving real deployment challenges for large enterprises like RBC, McKinsey, and Bell. They've proven that Canadian AI research can translate into practical solutions that compete globally while maintaining focus on what businesses actually need. AI that works in complex and often regulated environments. Cohere's partnership with the Canadian government on AI sovereignty and domestic compute infrastructure is a great example of how breakthrough research can drive economic benefits that stay here. That's why Nick is such a great person to have with us today as we explore some very key questions, such as how do we turn world-class research into economic advantage? And what does AI sovereignty actually mean in practice? As someone actively trying to balance research advancement with successful deployment, technical innovation with practical implementation, and enterprise adoption with Canadian values, Nick is uniquely positioned to address these challenges. And I think those challenges will determine whether Canada leads or lags in AI. So please join me in welcoming Nick to the stage. Thank you. You're on the Fireside. I'm a little worried they might start playing music to play us off. We'll see how that goes. So Nick, in terms of research going to commercial adoption, if we were to take a time machine to 2030 and then take a look back, what would you say Cohere's impact on Canada was? Beyond headlines, beyond valuation?
I mean, our objective as a business is to change the way work is done, right? There's, like, I think we're all pretty familiar and have incorporated bits of AI into our daily lives, right? Like lots of Google searches these days, people are looking at the LLM generated result. People are going to consumer chatbots to help them with little bits of tasks here and there. But if you look at the average knowledge worker, it's still hardly impacted the way they do work. That's not, I guess, too surprising when you look at the rollout of other technologies, right? There are still places where you have to fax things in, you know, so technology getting into enterprise does take time. But this technology is so useful, and there's such a real urgency to get it into enterprise that I think by 2030, you know, if we're successful, anybody who arrives to their desk to do work for the day will open up maybe an email client, and they'll open up some terminal for using an LLM. And anytime there's a boring task that they need to do, they'll get the AI to do it for them. So that's a pretty fundamental change to the way we do work, and that's what we're trying to do. We're trying to do that globally.
Right.
I think if we're able to succeed, if we're able to do that, that will affect the way Canada works, but it will also affect Canada's position as an AI leader, right? Like for the past several decades, most of the world's experience of technology has been defined by Silicon Valley, has been defined by America. And I think at this stage, we're all pretty aware that that isn't great, that the vision of life, that the view of the way the world should be coming out of Silicon Valley is not really the one that a lot of the world wants, especially, it's not the one that Canada wants, it's not the one that Europe wants. So, if Cohere is able to be successful and we transform the way work is done, I hope in the process we're able to help build up an AI ecosystem that means Canada doesn't need to be just following along the vision of tech that comes out of the States, but instead we can be making our own.
That's very inspiring. I'm with you on that.
Great.
I encourage everybody here, let's make that happen. So Cohere makes significant contributions to research while also building commercial products. So how do you actually balance that? How do you balance research with the pressures from product development?
Yeah, that's also a great question. So before this, I was at Google Brain, and while I was at Google Brain, this was in 2016, 2017 to 2020. During that time, I took pride in my lack of contribution to the products of Google. Every day that I came home, having done nothing of value, was a success as a researcher.
Okay.
Because I was like, well, if they're paying me to pontificate, how good must I be at pontification?
Pretty awesome.
Yeah, and so we did lots of work that was all very interesting, but none of it, like my objective was never, cool, am I making a better product?
Right.
I just wanted to work on pure research. And that was really fun, and I really encourage people to do some of that in their lives. I think thinking and research for research's sake is a great thing to do. And it leads to the types of things that we see now, right? Like if Jeff wasn't stubbornly thinking about the way the brain works or might works, he wouldn't have stayed with neural networks and they wouldn't be here right now.
Right.
So that's really important. But at some point, I got bored of that and I was like, what I want to do is build a product. I want to build things that people use. It turns out that if you're building AI systems, there's no way to build them without doing research. Right? Like there are novel questions that need novel answers, and you cannot build a good product for people unless you're tackling those questions. So it's important to carve a distinction between research, as in the idea of answering unanswered questions, with opening up LaTeX and publishing papers in the right format and like reviewing things. All the work that we do at Cohere is research, all of it. We're constantly answering questions. We're constantly trying to push boundaries, build things that haven't been built before. Some of that we publish. And we publish the things when we think we've discovered something that is relevant and interesting, and we do that for the purposes of notoriety and goodwill and attracting good talent and fostering a community. But the tension doesn't really exist.
Okay.
Because the work that we're doing necessitates novel research.
That sounds like it's fairly unique to AI.
I think that's pretty unique to AI. Yeah.
Yeah.
I think other companies where,
Maybe more distinct.
where what you need to do is kind of known, you just have to do a good job of it. Maybe there's a little more tension there.
Yeah. So maybe on some technical, and feel free to go as technical as you want for the researchers in the audience.
Yeah.
So Cohere has leaned hard into RAG embeddings and flexible deployment rather than chasing a single do-everything frontier model. So what contrarian technical bet did you make that you think is still maybe misunderstood in 2026?
Yeah, that's a good question. I think our investment in embedding models and RAG has been well, I don't know if it's contrarian, but it's certainly not exciting. Like we make the best embedding models. We make the best multimodal embedding models. We make super efficient embedding models that can be run we tried to get them down to binary embedding, but that didn't quite work. So, very, very small footprint of both the model and of the embeddings themselves. And I think I keep seeing people say like, oh, RAG is dead. Like, you don't need to do search. You just put it all in the context. And that works for cool kind of personal demos. Maybe that works for your own life, or you're going to do, you can just have an agent go through all the documents you've written on your computer, and like that'll be fine. But if you're operating at scale, if you're operating in an enterprise, that just continues to fail. Right. Like when you're looking at, like 10 million documents, yep. You can't have an agent load them up into context and ask, is this relevant to the question? Yes, no. Like you need a better search. And so our investment into embeddings and RAG continues to pay off in the enterprise deployment. And that's not obvious to people using this technology on a personal basis.
Right. Yeah, no, that makes sense. So you've also talked about not building a digital god.
Yeah.
So what's the vision for AI that you want Cohere and perhaps Canada to be known for?
Yeah. It's a good question too. Yeah, when I talk about not building a digital god, I mean to say a lot of what you hear from the labs these days about like the impending AGI, we're 2 steps away from turning on something that can do everything. Yeah. And it's kind of interesting. I feel like we're in a little bit of that arc again. Suddenly a bunch of people got exposed to coding models, and then every time the world gets exposed to something that is slightly better than they expected it to be, I see an uptick in the rhetoric of, okay, therefore, we're going to have a digital god in a second. But we kind of forget, like 2 years ago, 2023, there was routinely discussion about the end of the world. Yep. There was routine discussion about people saying, we're about to build a thing that will create a bioweapon and kill all people. Yep. I like to ask this question when giving talks, and it's particularly interesting when giving talks like at the Vector Institute. But how many of you think LLMs pose an existential threat to humanity? A show of hands.
Oh, I'm not seeing a ton.
1.
I think I saw 2.
2? 2. Okay, cool. Sorry to put you on the spot there, but so 2. So there was a moment in 2023 where I think if I asked that question, even at the Vector Institute, there would have been more hands, right? And that's certainly, like, you can go back and read breathless articles from any journalist talking about how we are, we're minutes away from this. I don't think that's what autoregressive sequence models are. I don't think they pose a threat like that. I think by the nature of how they are built and how they work, they have fundamental limitations. I think those limitations are drastically underestimated by people, and you can build truly like economy-changing, world-changing technology with LLMs. And that's what we're seeing right now, and people are excited about coding models. And you can imagine how that kind of coding models are going to be able to do stuff like they're doing for coding for every work that's done on a computer. But I don't think we're going to build something that you treat as a person. I don't think we're going to build something that you have an expectation of, that you collaborate with in the same way you collaborate with people. And when I talk about not building a digital god, that's what I'm talking about. I'm saying, hey, we have to acknowledge this as a technology, super useful, going to fundamentally change the way computers work, the way the economy works, but it is not the AI of sci-fi. It's not just a really smart person in a computer. It's not a god inside a computer. It is something else, and that's important to focus on. So when, what do I want us to, be known for? As the years go on and that vision of reality of we're about to be able to solve all problems, you're going to be left behind, there's going to be no jobs anymore, it's just going to be this one computer sitting in one place doing everything. As that becomes more and more ridiculous, I want us to be known for actually understanding how the tech works and making something useful the entire time.
Right, because the World Economic Forum last year about this time came out and said they estimated 170 million new jobs with 92 million displaced, so a net of 78 million gain in terms of jobs. So I think the question there is, or maybe the point for us is, we want to make sure that at least our fair share, if not more, of those new jobs end up here in Canada, as opposed to elsewhere.
Yeah, I think if we play our cards right, we can do that.
Right. So if you think back to your academic work, what research insights from that work proved most valuable when building Cohere's models, if any?
Yeah. Well, my academic history is pretty short, actually. Right? Like I have an undergrad from U of T, and that's it. The Vector Institute didn't exist when I was an undergrad, and had it existed, maybe I would have gone to the Vector Institute. But so at the time, I went to Google and then transitioned into a research role within Google Brain. While I was at Google Brain, I spent a lot of time working on adversarial examples, and those are not that relevant. A lot of the work that I did at the time was was complaining about whether or not they were relevant, and arguing that they weren't really relevant, and they continue to not be super relevant. They're useful because they remind you that the technology you're working on is a statistical model of a data set, and the properties of that data set you're using as a proxy for the world, and it's not a perfect proxy, and that's what adversarial examples can teach you. I also spent a lot of time working on capsule networks, which are also not relevant, not useful at all. People were very excited about them for a year there, or 2 years, but they didn't scale. And that turned out to be the main thing we needed neural nets to do. So when I first found out about transformers, I was really excited about them because I thought what they were doing was what capsule networks was trying to do, but in a way that could scale.
Right.
Yeah, so this is an argument I have had with Jeff many times. He does not agree with this view. He does not think transformers do what capsule networks were trying to do. But at the time, I was like, okay, they are. And what they're doing, and what capsule networks were trying to do was coincidence detection. It was trying to say, in a standard neural net, there's only one way for a neuron to be active. It could be more or less active, but you're taking the learned weight matrix, applying it to the activations at the level below, and the neuron is either a little bit on or not on, or on a lot. You have some nonlinearity in there, but there's only one direction it can be on in. A capsule network was trying to have a unit that could be on in many different ways. It could say, yes, I'm seeing the feature that I've been trained to see, and I'm seeing it in this position at this coordinate, like with this style, in this tone of voice or something like that, whatever modality you're working in. But we were never able to train those up and scale them with huge networks. It just the algorithms that we were using for finding that activation were really inefficient. They couldn't be hardware accelerated super easily, and so we could only ever get them to work on pretty small models. A transformer with its significantly less complicated activation than capsule networks, but at least more complicated than a regular neuron, can be on in multiple ways. Right. It's comparing a key and a value, and it's saying these two have agreement, and it can be on stronger in that direction or in this direction. So that's why I bought in to transformers really early. That's why when I found out about them, I was like, this is huge, and we should go build a company.
Because you could see the difference.
Because I was excited about what this model was doing, and about the early results. Has that been useful in the past 6 years of running a company? No, no, I don't think about that very much. But certainly the stuff that I learned in research, thinking about the fundamentals, thinking about how neural networks actually work, thinking about what assumptions we're making that are not true, all of those all of the work that I did in writing papers, in figuring out how to critique papers, that is helpful for running a business every single day.
Right. Yeah. Thanks. I do want to dig in on Canada's AI ecosystem. So there's a narrative that says Canada repeatedly invents world-class tech. AI is an example of that. Yeah. And then watches the value accrue elsewhere.
Yeah.
So what are you doing differently at Cohere so that this time around the economic and strategic upside stays here?
Yeah, well, I guess we've stayed
Canada?
stayed in Canada. We're not leaving. We like it here. We live here. This is our home. This is where we've invested. This turns out to be a great place to start a company. There's people around the world who want to move here, so it's very easy to have the smartest people want to move here and start a family and join a community. There are lots of exciting businesses starting here and legacy businesses that are moving really quickly, even though they're 150 years old. So it is a great place. And yeah, I think we're dedicated to supporting the country and building a world-class company here.
So given Canada's new domestic compute infrastructure, and you guys are part of that, what research questions are you able to answer now or ask now that maybe you weren't able to 3 years ago? So is there anything you can do today because there's more compute available?
Oh, well, yeah, so 3 years ago we were a much smaller company.
Yep.
And I know I'm preaching to the choir here at Vector, but having access to more compute is good for research. Yeah, I know, and I also know, yeah, I speak from a place of privilege of this. Like I remember when I was doing my first research, it was on Google Colabs with models that I could, print out and visualize all of the weights of. So it's certainly come a long way to training, 100 billion plus parameter models. It's an interesting dynamic, and one that I think still doesn't have a good theoretical answer. Why is it that some things work in transformers at a small scale that don't work at a large scale, or vice versa? Right? Like if you want to make the best model, you can't iterate on a small model and iterate all the hyperparameters on a small model and then just apply those to the big model. They're actually different hyperparameters. And that means you have to iterate at a large scale. That's why that is a great question. And if there's researchers in the audience interested in that, they're doing work to figure out how can I train an optimal transformer with 3 million parameters and get the right parameters for 3 billion parameter model or something, would be an excellent research direction for people to go in. But so what is the research that we can do now that we have compute? Well, we can do research on building frontier foundational models, and we couldn't do that without the compute.
Yeah. And I was just thinking about your potential research question there. Presumably we could answer the 3 million versus the 3 billion. We could actually better optimize the use of compute.
Yeah,
so we could say,
absolutely.
do this here and do that there.
Yeah.
All right, one last question, but I did want to see if there was anybody in the audience that might have a question. I'm not seeing any hands. All right, you're going to go with mine. My last question is a fill in the blanks type of question.
Fill in the blank.
Fill in the blank. So, the most overrated risk in AI today is?
The most overrated risk?
Yep, and the most underrated risk in AI is?
Yeah. I think, the most overrated is the existential threat.
We're going to die tomorrow.
Is somehow a technology, somehow an autoregressive feed-forward probabilistic model of text is going to spontaneously get not only will, but malicious intent. The idea that we're just going to, suddenly this statistical model of text is going to want to and act out global murder. Yeah, that's the most overrated. That's the most overrated risk.
And the most underrated risk.
I think the most underrated is that the infrastructure of the internet and our experience of it is as a result of a bunch of dynamics that were already at play, but then exacerbated by the widespread adoption and use of LLMs, the internet is kind of crumbling. And that people's experience of it now is a lot different than it used to be, and that experience is largely negative. So I think that's maybe the most underrated. Or another I think answer on the economic side of things is that overrated risk is the complete reduction of all jobs.
Right.
The idea that, okay, cool, suddenly, we have LLMs that are really good at text and really good at programming and really good at doing stuff on computers, and therefore jobs won't work. Like, I think that's a fundamental misunderstanding of the way the economy works. It's dynamic and reflective and responsive, and as we have introduced new technology, the nature of the workforce has changed completely, right? Like, we used to be 94%, 95% before the Industrial Revolution. Farmers were like 3%, 2% farmers now. So, that's a huge reduction in jobs, and yet there's more people employed. There's more jobs out there because of the nature of our dynamic economy. So, overrated, all jobs are going to be gone. Underrated, this technology, if not rolled out with really good policy, could exacerbate income inequality.
Right.
And that's something I'm worried about. That's something I think we need to get right. Like, when we went through the last Industrial Revolution, there was a lot of policy that was written to make sure that there were still good worker rights, there was still good distribution, and that resulted in a century of enormous prosperity, right? So we need to make sure similarly that we're doing the policy work now to make sure that this technology is a net benefit to everybody.
Excellent. Great way to finish off, and thank you, Nick. It's always a privilege and a pleasure to talk to you. I always feel like I get a bit smarter, so that's always good.
Thank you.
So thank you again, and thanks everybody for joining us.